Hello, everyone. Welcome to this webinar for East Focus. My name is Giovanni Ortiz from DOS Audio of America, and I'm the tech support and applications engineer. So I'm pretty sure you guys have all either heard of East Focus or any of these softwares before. You've used our AERO Series, event series. You have most likely have used this in some way or at least heard of it. I will be here to help you guys learn a little bit more of how to use East Focus to better set up your line arrays in a live application or even in an install if you need to. Let's see. See, there's 84 of us here today, so hopefully you all will be able to enjoy this webinar. So let's why don't we get started since we all are here. Before we actually fully go into the webinar, I have handouts at the bottom of our page of an image that we'll be using during our project and a PDF version of this webinar. If you guys would like to download it, have a copy with you, go through it with us, just in case you miss anything, you have something to go back to. I believe that in your welcome message, you have received a link. You can download the newest version of East Focus and our GLOs. In the meantime, why don't you guys take a second, start downloading that, and you can have that ready and follow along with us in this presentation. Just so you guys know, East Focus is a Windows-only software. Sometimes, depending on different versions of Windows, you might need to download a framework add-on to make East Focus work. This is only for emergency purposes. Sometimes your Windows will not have proper settings that it needs to install the software. Thus, here's a link to download the proper framework to get that working. Again, this is not something that happens all the time, but we have run into instances where a framework download is needed. Also, the hardware aspect of the computer needs at least 2 gigs of RAM, 1.5 gigahertz processor, preferably multi-core, 2 enough, and 30 gigs of free hard drive space. Reason why is that it does do a lot of computing. It does have a lot of video aspects to it, so your GPU needs to be a little bit powerful. If not, there are settings inside East Focus that you can downgrade the resolution. If you ever get lost and need to download East Focus, you lost it or need the newest version, you can definitely go to our website, dosaudio.com, and be able to download East Focus from there, plus all of our newest GLOs. Normally, we download them as a bundle and keep them all together. One other thing that we got to do is once we've downloaded East Focus and installed it, we need to make sure that we have all our GLOs. It didn't come in the same zip file as the East Focus. You can go to our websites and download them individually from our products websites. Go into an AERO 40, select AERO 40, go to downloads, and you should be able to find our download all of our softwares with our GLOs or individually from each product's direct website. Once we've installed East Focus and have been able to open it up, we will be able to import our GLOs. To import our GLOs, we'll be doing that inside file import system definition. If you guys are looking at my screens, we will be able to go to File, Import Definitions, and then go and select your AERO 40, which it should have been in the drop folder link that you got in the email. Or if you see the welcome link of this webinar, you should download from there, this one. Once we do that, we can press open, select it, open, and it'll start to import our system definition, which is our GLL. What is a GLL and how are they created? A GLL is a digital copy of, so looks like somebody does not have sound. A GLL is a file that is created under Speaker Lab. It's pretty much a digital copy of our speaker from every angle. Pretty much they put the box inside of an anechoic chamber with a microphone about 1 meter away. And there's a machine in there that rotates the speaker as it's outputting pink noise. With that, you're able to capture how the frequencies resonate from the box to the mic towards the microphone point and be able to capture a full digital audio acoustical capture of the box itself. Once we have how the box digitally sounds in the program, we're able to add our mechanics, how much the box weighs, the angles of the box, how the bumpers pinpoints work with gravity, how all boxes together work with gravity, and be able and how it works together. Once it has all of this information to compile everything into a GLL, so that way when you put it into EaseFocus, we can comfortably know that we are using a realistic algorithm of our boxes to properly calculate what we're trying to accomplish in our scenario. We're going to go over a couple of settings that I like to, that we at DOS like to set up in our options menu to kind of better have us go through our products and go through our session and have easier use of manipulating our product. At first, we're going to go to file options. I'm going to show you guys hands-on. We'll go to options or F9, file options, and here we're going to start an environment. Under environment, we'll be able to change our units, which is imperial units, which is feet, pounds, Fahrenheit, or we can switch it to metric, meters, kilograms, and Celsius. For the sake of this project, we'll be using metric. The second part that I like to change in here is functionality mode from standard to extended. The reason why we like to use extended is that it gives us more frequencies that we could go through in our mapping, plus opens up a bunch of other windows for us to utilize. Filter, time response, so on and so forth. Under frequency, well, first we'll go to view, and under view, we'll be able to add a couple of rulers that I think, let me see. Under ruler. So normally it comes out like this. Top view means the rulers are empty. Let's go ahead and turn on the ruler. That way, while we are working, we can see what our actual dimensions are. Our 0 point, what 300 meters is on our XY path, and also on our Z. Color mapping. Color mapping. Color mapping is going to help us work with how the coloration of our imagery functions. Pretty much, we'll be able to select automatic or manual, which manual will allow us to select a maximum number of dB level and a minimum dB level for our coloration. Pretty much, I'll show you in our presentation. In automatic scale, if we're working with different speakers and stuff, and we're constantly changing between it, the coloration is always changing. It doesn't stay static. So sometimes it might be able to, you might get confused and not know exactly what you're looking at. If you look at the image here, this is the exact same speaker in the exact same place with its automatic scale and a manual scale. If you look at the time frequency response, you'll see that 80 hertz and 90 dB is the same in this picture, in the automatic picture, than it is in the manual picture. But it still is 90 dBs per 80 hertz. The only thing that changes is our coloration of the scale. If you look at the scale in the automatic, it says pretty much from 50 up to 100 is our scaling range. But in the manual, we have from 70 to 115. Next, we're going to go to frequency response. Under frequency response, we'll be able to change the frequency chart from bar chart to line chart. We typically like to use line chart only for the reason it's pretty much how we're going to see it in SMART or any other FFT that we utilize to control our system or tune our system. Parameters of calculations. Here we're going to talk about power sum and complex sum. Power sum and complex sum is a feature that ease focuses always have. Complex sum being one that is new to ease focus 3. What do I mean by complex sum and power sum? Well, complex sum pretty much looks more into, helps us figure out more what's going on with our sub frequencies. Reason being that we'll be able to see where things cancel out or sum up. In power sum, all we really get to see is all the energy radiating in all direction and it's summing up. You don't really get to see where it's canceling and where it's not. But in complex sum, we have the opportunity to see where the interaction of the subwoofers that are at 2 different points and how they interact. So since we normally use them for subwoofers, I cut them off at about 125. So that way, once we get into the 125 range, we'll be able to see all the interactions between the subs. Also, when we use power sum, it focuses more into the high frequency range, just because we want to we want to see where all the audio is going from. All higher frequency ranges will tend to be blown away with the wind the higher you get. So having to see where it cancels in a projection kind of limits our perception of the frequencies. Now, if it's something that's static and you want to see where you're getting cancellations in certain high frequencies, yeah, we can definitely raise the complex sum up to 16K and see how all the frequencies are interacting with each other. But normally, we just use the complex sum to focus on the subrate to get a better understanding of where our subs are summing up and canceling. In ease focus, we have a couple of windows that are very important for us to utilize in our project simulation. If we look at number one will be our top view. Number 2 will be our side view. Number 3, our object properties view or project properties view. Number 4, our installation or rating view, and our number 5 being our mapping toolbar. Number 1 is pretty much where we're going to be interacting mostly with our products. We'll be able to create our audience areas, audience zones, drop in our speakers, drop in an image of our background, like a PNG of an AutoCAD or a JPEG of an AutoCAD that we can fit into the screen. Number two, side view. Anything that we do on the top view, we'll be able to automatically see in the side view, and we can also manipulate a couple of angles in the side view as well. Number three is pretty much where we're going to do all of our work, inputting information, X, Y, Z, which is our width, our depth, and our height. We can play around with our speakers, select the configuration, name our speakers, create limits, do all the configurations of the filters in the back, and then we do in the back of the unit or in .NET. We also use autosplay, which is our ease focus algorithm to find our proper angles for each box. Number four gives us all the information that we need for rating our speakers. Once we have calculated everything, we'll be able to look at our rigging and see how much the whole array weighs, the length of the array, the height from the bottom box to the ground, the angle of the bottom box, and what the width of the entire array is. Very informative window, one that I look at constantly, especially when I'm already ready to install my speakers. And then mapping is what allows us to interact with what we're seeing in the coloration down there. We have our SPL types, A-weighted, Z-weighted, or signal to noise ratio. We have our frequency ranges that we can select through, but the only way that we can select our frequencies is by making sure that our broadband is here, I'll show you guys this. Here under bandwidth, once we are able to select a type of bandwidth, a third octave, that opens up the range for us to see all of our frequencies. In our mapping as well, we have A-weighted, Z-weighted, and signal noise ratio. A-weighted being comparable to human hearing, Z-weighted being all frequencies at pretty much at 0. Frequency ranges, that extended that we did in the beginning under environment allows us to have more options in the frequency range. You notice if we go back to extended, I lose a bunch of tabs down in the side view area, plus my frequency range only goes up to 31 Hertz, very small range of frequencies. If we go back to extended, we'll be able to utilize more options, we'll be able to see more information and have more frequency range of which we can dive into. Up here, we'll also be able to use sources and areas, which is pretty much our mute buttons for this project once for our mapping. Let's go back. All right, so the first window that's pretty important when we first open Ease Focus is our project properties window. In this project property, we'll be able to see everything that's going on in our project. We get to type in our name of the project. So let's say this is an outdoor venue. We can put our name. My name is Gio, who's creating it, and the company that's doing it is DOS Audio, so on and so forth. If we're passing information, or you've been taking measurements, you can definitely type in all your measurements here, stage dimensions, or area, things, so on and so forth. Now, what I really want to get into is to the bottom area down here, where it says temperature, air pressure, and humidity. This is actually very important for our project. Reason being is that this allows us to, I didn't change this into English, not that guys. So pretty much what we're looking at here is our frequency responses, right? From 31 Hertz to 20K. If we focus on this in this high-end area, from 5K to 16K, the first one we're looking at is at about 20 degrees Celsius at 60% humidity. If we just drop the temperature by 10 degrees and the humidity by 20 degrees, we lose all of these high frequencies. Reason that happens is how the temperature works. You know, higher frequencies, hotter with more humidity gives us more particles out in the air, which gives our high frequencies something to travel through a lot easier. When we drop it 10 degrees and take away the humidity, there's less particle in the air, there's less energy in the air because of temperature, it's colder, thus our high frequencies don't go as farther distance. So an easier way to conclude this is that maybe this will tell me, hey, I might need to raise my throws or put a high shelf on my high frequencies because it's getting cold out and I need to bring a couple of the high frequencies back into my system. So like I said, it's very important to put in what the temperature is around you. Now, air pressure, humidity, if you look at the settings, they're just averages. There's a low, medium, low, standard, high, and same for humidity, low, standard, high. So if you just know that it's low humidity, it's a normal day humidity or high humidity, that's all the information you really need. The one that helps you really get into everything, put these two into place, is the temperature. Once you put the temperature and select your humidity, it will change your high frequencies accordingly. In this window, we also have project settings. Project settings is where we are allowed to edit our ear heights for our projects. Seating height, standard heights, if you notice it already comes with a standard, some numbers already in there, which are basic, 1.2 meters for sitting, 1.7 meters for standing, and we have a custom. That way, if you needed to do something odd, you'd be able to put something in there and save it without having to disrupt your other two ear heights. This default limit height is for our sound sources. This is an overall limit for our project. Say your roof is only 30 feet high and you put a speaker in here and you accidentally put it at 30 feet high. This will allow you to give you a feedback to tell you that it's gone over its metering. So since we have 8 meters here as our limit and I select yes, I'm going to put quickly a device like this one, standard box. If you notice, we're underneath the limit. I'm going to select this box real quick and put it at a height of 8 meters. The rigging section shows me that the top of that box is at 8 meters. But if I go to 8.5 meters, now it's telling me that I have surpassed the limits of that I've set into here. So it's a good way to set a limit for your entire project, and if you accidentally put something too high, you can definitely double back and change your heights afterwards. We'll go ahead and take off that limit. Ear heights. In the top view, these are all the buttons that we have to manipulate all our objects or set our zones and systems. We have our zoom in, zoom to fit, zoom out, which are all just manipulating the sizing of your project. Add an image is so we can add a photo or a screenshot of the DWG file that we have and be able to superimpose it into our project so we can have an outline of our audience areas. Then we have different shapes of audience areas, or audience zones, I should say, to better attack our projects. We have a rectangular, a circular, angular, and trapezoid. All of these are just basic shapes, and then we have a right angle trapezoid. Add a system is where we'll be able to go to select any of our systems, our GLLs that we've inputted, our system definitions, and be able to drop them into our project. A selection plane allows us to, we'll talk about that in a previous slide, but it pretty much allows us to see our image from a different perspective. Then we also have our microphones, pretty much what we try to be measuring with in a real scenario. This will allow us to see it in our virtual world, in our virtual system. So what are the basic things that we're trying to measure in Ease Focus? At least what are we trying, before we get into Ease Focus and we're on the sites at location, what are we trying to measure? Well, basically we want to know our stage heights, the measurement from the floor to the rigging point. So right where your rigging point is, all the way down to the ground, you want to measure that point. The height of the stage to the rigging point. Sometimes we have to rig inside of our stage, so our limit to the ground might be actually the stage and not the floor. Distance between bumpers and rigging, so that way we know an adequate height that we have left over of if we need to raise boxes higher. Distance between bumpers and rigging points. Floor to bumper point, floor to stage, stage to bumper point as well. These are all important measurements, only to make sure that you're putting things accurately into place. Yes. No. Measurement of your XYZ sites is also very important. This is pretty much your width, your depth, and your maximum height for your PA and your audience area. Distance between rigging points is also very important, so we actually understand how far our coverage is. This will allow us to find out if we need front fills in our system setup or not, and so forth. These are basic tools of our trade. We have a laser distro to measure any basic distances, pretty much our the height of our rigging points, the width of our stage, so on and so forth. We also have an inclinometer and a rangefinder. Now, most lasers nowadays also have an inclinometer, so that way you can find the angles of your bottom boxes, or if you have a tilt on stage, you need to calculate that as well, or to find the tilt of your audience area, so on and so forth. Rangefinder is a new object that we've been using lately. It's pretty much a little scope that you can shoot a distance and see how far you are shooting. This is great during the day, especially when our lasers are it's too hot outside or too bright outside, and our laser doesn't bounce back and doesn't calculate a proper distance for us. We'll be able to use a rangefinder to calculate our distance during the day, and you get a greater distance, and the light doesn't obstruct your measurement. A cool thing about the rangefinder tool is that it does calculate for our angles. You know, if you're looking from your perspective and look straight across, it'll tell you that you're at 0 degree. But it can also calculate if you have to look upwards a little bit, it can tell you how much of a tilt you are looking at. So like I said, these are the basic tools that we want to use in when we're measuring our audience areas and such. DWG files. Now I would have really have liked for this program to be able to input DMG importing, but we don't have that option. So if you have DWG files that you want to be able to use as a background for your Ease Focus, we can do this, but it has to be pretty much a screenshot of the image and be able to import it into our project. Here's an example. In this button right here, we're going to add an image, layout picture. I have an image ready prepared right here, open, and this is our image. Now, if I'm at this location, I would be standing pretty much dead center of the stage, and I'm going to measure my distance to the back of the venue, which I already know is going to be 80 meters in this case. So now I have to put this image into scale, so the program knows exactly what size this image should be. So if I know that from the middle of the stage, directly in the middle of the stage, to the back of the venue is 80 meters. I'll just drag A and B to its proper points, as close as possible. And I will put my X points at 80. At 0. My Y at 0, which means this point right here, A, it's now going to be my center origin point, 0, 0. My cardinal point of 0, 0. And the other portion is going to be point B, which is going to tell me the exact line length of the line that I drew, which I will put 80 meters. Opacity would be how bright or how see-through this is in the back of the image, in the back of the project that we're going to be working on. Now notice, there's going to be times where the image is going to look super small and you're going to get a really fine point. If you notice, off into the right-hand corner, my cursor becomes a magnifying glass as well, so I can see where I'm looking at. Once I've set these points, I am ready to press OK and implement the picture into these focus. So you notice now I could actually have the image there and start working. I can crop things out, so on and so forth. All right, before we continue with each focus, let's have a little tutorial of what we have to accomplish in line arrays and a line array compensation, and how we're going to find that in each focus to better set up our line arrays in the digital formats. So when we go in a real world scenario, we'll be able to implement it there. So as we all know, at least most of us know about line arrays, the more boxes that we add together, the more low mid summation we're going to get. Low mids just have a tendency to start building up. So in a line array situation, what we're trying to do is bring our high frequency range back to where it needs to be, compensate for all the low mids that have summed up. Here's a little example of what one box does in frequency ranges. So in this array, we have everything else muted but one box. So at 8K, we are shooting very directional. We're going all the way to the back of that audience area. And you can tell by the line in the center, the curvature line that you see there, that is a level over distance. So we can see that our level tends to get a little louder over distance. One, because it's the top box and it's shooting towards the back of the area. Two is because that high frequency tends to go further and more directional. That same box at 100 hertz radiates outwards towards the back of the box, in the front of the box, than everywhere else. So if I had all those 8 boxes turned on, and 100 hertz or around that area tends to sum up greatly. So we tend to lose all of our high frequency ranges. Not because they're not going, it's just because all of our low mids and the boxes have summed up. Example, in these in smarts, if I have this configuration of 4 and that little guy right there is one of us standing there and it's on, we'll pretty much register that box as flat, or at least how the box should sound. Once I add in another box, I'm already gained 3 dB, just about 3 dB summation from 5K and up technically. But if you notice that 5K, 5K and down, 5K and up stays the same. If I add another box, excuse me, we've almost doubled that again. And the 4th box, we tend to double it again. So if you notice, we just keep summing up all those low mid frequencies, but our high frequencies stay the same. This is the reason why all of our boxes have number of units. Number of units is pretty much our array compensation. It's going to bring up those high frequencies back to where it needs to be, so that way that PA sounds the same way as one box. This is a picture of what the number of units in an event 212 or a 26 would look like. And this is what a 4 boxes of 4 DOS boxes would look like once we have the number of units set in. So let's say these were event 212s. If we had all 4 boxes without the number of units placed in, it would look something like the top, the green line you see here. Once we add the number of units to 4, it balances out to back to what it would be in as 1 box. So like I said, this is our array compensation for our high frequencies in an alignment situation. So now that I've gone over East Focus a little bit, this is pretty much part 1 of East Focus. I'm going to go do a little hands-on building right now with East Focus, and we'll then go into a part 2, not tomorrow but Thursday. Part 2 is going to be the rest of the other half of East Focus, mainly to do with subwoofers and stuff like that. So let me show you guys a little bit of East Focus hands-on, just so we can go through the rest of the windows and parameters. I'm going to turn off mapping first. So like you saw me do before, I have put in this outline of the event. We know that it's 80 meters long, and now that we know that it's 80 meters long, we can see what the width of this project can be. We can find out the width of our stage, the width of our audience area. An easy way to do that is to look at our rulers on the side, which here tells me that it's 25 meters from center in either direction. Or another way I could do that is shift. Once I hold shift, my cursor turns from a little hand to a crosshair. Then I'll be able to bring out a little measuring tool. And if you notice, it's not only telling me distance, but possible milliseconds. What I could use that milliseconds for is to gauge roughly in milliseconds what my front fills would be to my PA or so, or from our delay system to our main PA. Now that delay is not going to be exact. It's not going to work exact, but it's just something to calculate and give you more information on what's going on. So let's bring out our AERO 20. Now, if you guys have already downloaded all the stuff in the beginning of this webinar and opened up, you can probably follow along with me in this project. I'm going to go through this a little bit and then open up for questions in about 15 minutes or so. So if you guys have already inputted your GLO, which one more time, we're going to go to File, Import System Definitions. You're going to find the GLO that you downloaded, press Open, and then it's going to load in, and we'll be able to utilize that. The next thing we're going to do is that if you guys also have the image, let's go to Image Layout one more time. Make sure that you browse and select the image that I sent you guys. Move point A to the center of the stage, point B to the end of the venue. X will make it as 0, Y as 0 to make this our origin point, and then point B will put it at 80 meters. Then we'll press OK. Once we do that, we're going to get our audience area that's already there, and we'll put it into size. Now, we're not going to need to put any actual information to our width and depth, only because we've done that to our image, and we can now scale our audience area, audience zone directly to the size that we want to cover. Next, we're going to actually shorten the area of the audience area within this audience zone. Now, I know it's going to get a little confusing right now. There are 2 types of audience area or audience zones. We have our primary audience zone, which is the entire square that we dropped. Anytime we pull one of these out, it's an audience zone. In this audience zone, I can divide it into different audience areas, meaning I can chop it up into different scalings, have different levels, have or have a VIP area, have a balcony, so on and so forth. For this example, we're going to use a we're going to break it up into a couple of areas. We're going to do 3 areas. So we're going to name them also area level 1. I mean audience zone level 1, audience area level 2, and level 3. This is the part that we're going to be introducing those tools that I talked about earlier, our laser, rangefinder, and inclinometer. There are many times that I run a situation and the first floor does not go all the way to the back of the venue. Maybe only goes halfway because there's a concierge behind that wall, or a service station that you can get your beverages and stuff like that. Let's say that this is all indoors. So if level 1 goes all the way to 75 feet and 75 meters, let's actually bring that down to 35 meters. And let's do 40 meters. If you notice in the front, on the top view, from the front of the stage up to the barricade, we have a distance that is not occupied by the audience. Now, I could actually use my little measuring tool and see what that distance is. It's roughly 7 meters away. So now on the 8-point in level 1, I can put in the 8-point to start at 7 meters and completely take out that portion of this that stage area or the walkway area and not calculate that from an audience area. For the second level, I'm going to start at 40 because let's say that's what I measured for the distances that we got in the project or the live scenario. And then I'm going to put it at a height of 5 meters. Now, the back area, I'm going to place it at, let's say, 60 meters. But normally on these balconies, they have an incline. The great way to figure out that incline is within the inclinometer, or if you have the laser that has that, you can put a little board on that staircase, put that the inclinometer on there, and it'll tell you the degrees of angulation that you have in that balcony. With that angle, we'll be able to say, let's say if I have a 5-degree, actually a 4-degree incline, 4 degrees, and now our distance between 40 meters to 60 meters is now going to be angled as you see here. What do we have? Our third area, and that's angled even more. Well, we'll go place, we'll measure it. We'll make sure that this is at 60. That's where that starts, a little bit higher, and it ends at 75, which is the end of our venue. Let's say that it has a degree of 8. We'll measure that, and now we can put that, and we'll have a star degrees. There's also places that have a degree of 15 or more. We can even go up to 50 if we need to. It's not really ideal, but just saying that there are options to get the angles that you need in your audience group, in your audience area. So we're gonna actually put it to the 20 degree. So that's how we're going to work with our audience areas. If you notice that our audience zone is still all intact, all of these areas are within the one zone. Next, we're going to put out our speaker. Now that we have our audience area the way we want it and we want to start mapping that out, we're going to use our AERO 40. So we'll go to the little J curve, we'll select standard, and we'll go to DOS audio. In DOS audio, we'll see AERO 40-20 version 3.52. This is the latest version we have for the AERO 40 AERO 20. Now, some people out there is like, why is it AERO 40 and AERO 20? Well, this GLO actually compiles more than one speaker together because they can be used together. Load a second. Once once you select the box, it's gonna follow your cursor to just pick the point that you want to drop it in. This is probably where we're gonna have our rigging point. I'll just drop it in there, and then I'll be able to change the orientation of the boxes as needed, or at least this coordinal pinpoint. It's better places. Let it finish loading. Okay. There we go. So if 0 is the beginning of our audience area, and I know that my speaker is a meter back from the front of the stage, I'm going to put -1 meter. That'll be there. And then to fit it right in the square, because I know that's right where I need it to be, I'm going to put it at 14.5 meters. So. Now I have the mapping off. I placed the speaker there. I see that in the rigging window that it's just a cluster of 840s with no angle points. If we're looking at our object properties window, we can see our position orientation, which is where we can change our heights of the top box, our cardinal positioning of the box, our horizontal or vertical orientation of the box. On the top of here, top of the object properties, we see system parameters. In system parameters, that allows us to label the box, but we'll call this one AERO 40 right. Or we can call it main PA right. In the setup drop-down menu is where we can select the types of boxes that work together that we want to use right now. If you notice, we have AX and AXS. The difference between AX and AXS is our ground stacking versus flown. AX is for anything that we want to fly, our AX S3 bumper. AXS is anything we want to ground stack. We also have our LX118. The reason why the LX118 is in here as well, and the UX818 is that we can fly speakers under that. We can create a cluster of subwoofers and then fly 40s in the exact same cluster, being that the 218 and the 40s will be compatible together, and the LX118 and the 20s would be compatible together. Here's an example. If I go to our sub, it's going to show us 8 subs, right? 1 sub and 740s. You can see it in the rigging window. You can see it written out over here. So we can literally build that in real life if we need to, if we have the proper rigging hardware. For this project, we'll be using the AERO 40 S3. There's 2 other buttons over here, rigging and filter settings. Rigging and filter settings is pretty much what we're going to be using to find out what angles we're going to put on our boxes, plus how we set each box to work. What do I mean by that? So if you know our boxes or know about array composition, this is where we're going to be changing our numbers of units and our throws. Same way we would change it in the back of the boxes, we would have to do it individually here for each box and, in the project. So in this case, we have a hang of 8, right? So I'm going to make sure that each box is a number of units of 8, and I'm going to go down the line and start off with mid-throw on everything. I always start on mid-throw on everything only because I need to calculate what my angles are before I see if if I need more highs in one area in the back area or more lows. I mean less highs in the front area. And this is something you calculate after the fact. But to start off everything, we always want to use our array compensation, our number of units. So we use 8 units. We're going to set in the back of the box or in DOSNet 8 units for each individual box. In rigging, allows us to select the amount of boxes we want in our cluster, also see the weight and the pinpoint and delta of our array. We also have auto split. Auto split, like I said earlier, is what we use to calculate our angles, or at least have each focus calculate our angles for us with these algorithms. If we select auto split, there are three types of splays of auto split strategies: conventional, accurate, and spiral. Conventional is the algorithm best known for each focus. It's going to select whatever angles it deems fit for each box and place it for in a way that it thinks it will work best. Once you use it, you can still manipulate it and start changing little angles as you need, as you see fit. Accurate selects all frequencies the same. So pretty much it turns your line array into a constant curve array, in a sense. What do I mean by that? It means if I select accurate and it deems that every box, that the coverage would be best at every box being at 5 degrees, all boxes would be set at 5 degrees. Spiral would be incremental changes. So if it thinks the best angle for the second box would be 4, then the next one will be 5, the next one will be 6, the next one will be 7, the next one will be 8, so on and so forth. It incrementally changes the angles according to coverage settings. In this case, we are going to use this array and focus it only on levels 1 and 2 and use accurates. Conventional as the split. Once you've selected your upper and top box, your conventional display, your strategy, and the areas that you want to cover, press start, and let it do the rest of the work. Now, if you notice, I only have the boxes at about 8 meters high, and only have 8 boxes as well. It told me that at this point, the 3 boxes should be enough to cover the second floor, while the rest of the bottom floor gets the other 5 boxes. And now we'll turn on some color to kind of see what we look at. Now I have it in in manual. Let me take this off, go back to automatic. We can get a little bit of better coloration. Now, if you notice, I have to put it into automatic only so I can get the scaling that the program wants to see right now of its what it finds the highest and lowest. If I change it to automatic, I have my own scaling that I want here that I want to stay in. This is good. This is good to have it in manual most of the time because if you know your scaling coloration is always towards the scaling that you input, then there's no way that you're going to make your mistakes in calculating your SPL. There are times that I work very fast, and if I have it in automatic and I'm constantly changing between speakers that I'm trying to see the SPL and stuff, it tends to change the scaling on its own, and then red isn't always going to be 114. Maybe it's 90, maybe it's 120, so on and so forth. So I find it a little bit easier to set the ranges that you want. So in this case, I'm going to start off with 105 and 90, have that be my coverage. Actually, we'll just do it in automatic so we can get things by coverage. Once we've done everything, and you notice that I've only been working on one side this entire time. The reason why I've only been working on one side this entire time is that once I have the height selected properly, my angles set the way I want it, I like the coverage of that of the speaker on that side. I've done my filter settings and everything like that. Actually, if we look down at the imagery here, it looks like we have a little bit of less energy up in the second area. This might be actually a great time for me to introduce a little bit of highs. I can go in here and start changing the throws on those top three boxes, see if I can get a couple high frequencies. Obviously, I'm looking at it in broadband and power sum, which is all frequencies at the same time, but I'll be able to go to third octave and go to 20K and start seeing where my frequency ranges lie. But if you notice, at the same time as since I have the scaling automatic and I start switching between frequencies, the coloration stays the same, but my scaling on the right hand side is changing constantly. It's just trying to keep the coloration the same while changing its values, only so you can have something visual you can perceive. This is a great point, a great way to put in your manual and start looking at it the way that you need to look at it, which is by frequency and its actual amplitude. And now we can start seeing that at 12.5K, it's already getting to 98 dB or 96 dB in certain places. Then 100 degrees in certain places, so on and so forth. We'll see where all those frequencies are covered. Yeah, they're automatic. So once I've done my throws, once I've done the things that I wanted to do to calculate the coverage here, I can actually just copy and paste, Control C, Control V to the next location. Now, since we're working symmetrically, we selected our origin point to be the center of the stage at 0, 0. All we got to do is make sure that we're the exact same cardinal points as the right side, that we have on the right side as the left side. How do we do that? You notice on the right side, we have y as 14.5, x as -1, and z as 8.5. Well, once we select the left side, which I'll name as the left side, I can go in and change that I am 1 meter back from the front of the stage, and I am 14 meters negative, which is the opposite of 14.5, negative on y, which is the exact opposite of the other side. Enter, and it'll work into place. Looks like the image is not exactly set. So we'll round it out of that. But if you notice, since I copied and pasted, I don't have to go and set my angles anymore. I don't have to go and set my number of units, my throws anymore. My rigging angles are all the same. And I can actually see the coverage that I'm using in the audience. Now, if we need to put front bills or anything like that, that's where we can use our ground stacking abilities now. So let's say we want to use 40s as or AERO 20s as our ground stack. Excuse me. As our ground stack over now. We'll be able to select a 40. I normally put it off to the side first, once it loads. And that way I can start manipulating what I need. So once it loads onto the program, as you can see, it still kind of takes a little second to aggregate everything. I can go to setup and AXS 20s, ground stacked 20s. I'm gonna put it at, let's put it at 2 units. I only want a ground stack of 2 units. And normally these can either go onto the stage now that they're ground stacked, or on top of the subs in the front row, on carts if you have carts. So you want to account for that height. So if the stage, let's say the stage is 1.5 meters high. So I'm going to tell the height of the bottom box here is going to be 1.5 meters high. Now I can actually grab this on the top view and place this right at the front of the stage. right where I see I might need some from front fills, this little gap, see the coloration. Another cool thing that we have is that because we have AERO 20 and AERO 20 120s, if we need to cover a little bit lighter, I can just go here and switch this to AERO 20 120. Same for the top. Now I have 120 degrees coverage of my horizontal coverage. Don't forget to go into your filter settings and make sure that you have them in two stacks, because you always have to put the array compensation for these boxes. And then once you know the placement that you have put it and your cardinal positions and your heights, then we can also go first name it, 20 front fill left. Let's say we only need one more set of front fills. And now once that's done, I can copy, paste it, place it where I need it, and load. The fun thing about Windows is letting things load, takes a while. And let's line them up. If the first one is at a X of 3.5, oops, then we'll put the second one at 3.5, and move it 3, 4. All right. So now we've evenly spaced our front fills, we've placed our PA, so on and so forth. If we wanted to do outfills, we can pretty much do the same thing as well. We're just going to get another AERO 20 system, select it, AERO 20, and let's say that it's going to be just outside here. Now again, I don't have the proper measurements for this stuff, but I'm guesstimating and showing you the options that we have to find and placing our speakers where you need it. Once it loads, so we'll change this to AERO 20 hang, AX AERO 20. We'll select it as 6 boxes because it's only going to be a outfill. I'll go into my filter settings. Once it loads, then I'll make sure that I'll place everything at 6 units. A cool little trick that we have too is that if we want to do a little preset for these right now, I can actually go to edit, change system, line array presets, and then I can select AERO 20, 6 units, 6 units. Once I do that, it will change everything to mid throw and 6 units. So that's a quick little shortcut. But don't do that if you're already auto splayed, because then it's going to erase your auto splay and everything else like that. Sometimes it's just easier to go in and change everything accordingly. Well, now that we have our outfill, obviously we're not going to be pointing it in the exact same direction as our main PA. We can turn off our mapping. We can see our horizontal coverage now, and start turning it to get the little sections that we need to cover. Let's say we're trying to cover this little guy that's in this top right corner. You notice that we're at an angle of 42. We'll make this 1 or 2 meters behind and 16. And I'm going to call this AERO 20 outfill. Right. Once I do that, once I know, again, one more time, once I know I've done everything else the same, oh, don't forget, we have to put its height. Right now, it's always sitting at the ground. I'm gonna put it pretty much at the same height, if not something a little bit lower than our main PA. So I'll set it around 5 meters. Oh, we'll do it 7 meters. Yeah, that'll have to be good. Getting real nice and close to these guys. Once we do that, now we can do our auto display and select our top and bottom box. We'll select conventional, and we're only going to do the bottom floor because we only want to get this right here. This target is pretty much only getting. You're trying to select the one that you're covering with this straight line right here. Right now, it's only the first floor. So once we do that, I'll select start. Go calculate my angles, and then there we go. Now that's not the best angles right there because it's only aiming for this little section that's right over there. So if I see that, maybe I won't need all those boxes. Maybe I want to bring them down a bit or so. Let's do 4 boxes. And then we'll bring down the speakers to 500. And I'll split one more time. Let's see what we get. We're still getting. It's the reason why we're getting all of this. We're only aiming for this far distance. But if that's what we're looking for, and that's what we want, we can copy, paste it onto the other side, like I said, and move forward. Once we place it, we're going to go back and put all our cardinal points again, just to make sure we're all on the same page. You know, and then if we notice that we were 40 and the other one were 42 degrees, right? So let's make it 42 degrees negative. Should be just exactly how it should be. Right. With that being said, that's a quick overview of putting our systems on there. Next on Thursday, we'll be going into more delay systems and subwoofers configuration, and a little bit more of the rest of these focus. I'm going to show you guys really quick the mapping of this coverage, and now I'm going to open it up to Q&A. If you guys have any questions about East Focus, any concerns or something you want me to quickly go over real quick, please let me know. Right now, we'll open up our questionnaires for the next 30 minutes. So, no. So here I have Jared, who sent one earlier. What speakers do you import the GLLs files of? Well, for this webinar, we did the AERO 40, AERO 20s. Seems like we got another question here. 1 second. Daniel, how do you lock audiences in order to pan the top view without moving the area? Okay, so if I understand your question correctly, how do I lock this guy right here, this audience zone in place? Now, I actually cannot lock this. I cannot. A trick that I have to make sure if I do accidentally move this is this front and center point right here. If I know that that my audience area is always going to lock into the 0, 0 mark, the origin point, then if I move this accidentally all the way over here and I want this to go right back into place, all I got to do is type in 0, 0, and it moves my audience area right back to where I had it originally. Now, the only place you can lock is your audience zone. If you're working with this one speaker over here, or let's say the front bill, and you want still be looking from this perspective, I can actually lock the viewpoint from the front fill and start working on another speaker and kind of see where the differences are and so on and so forth. This would be actually a great example for muting and unmuting. If I select this up here, this is still looking at our 20, but I'm going to mute everything and only select our main PA left. Now, if you notice, I'm still looking on the side view from the angle of my front fill, but I'm seeing the coverage of my PA. So it's a good little back and forth that you can do there if you need to. But as for the top view, there is no locking. There is no locking. Jan, do you always shoot straight with male hangs? Not sure what you mean by male hang. Oh, main hangs. Straight? What do you mean straight? As in, straight down my audience area? Yeah, normally my PA, I try to keep it as straight. There are occasions that I have to toe in my PA. A great example would be in a real world scenario would be I'm trying to get less reflections off the side wall. Or I need to get, I don't have enough front fills to cover all the way in the front area. So I need to toe it in to make sure my my horizontal dispersion gets to the front row necessarily. So say I didn't have front fills here and I only had my left and right. That little gap that you have right there in the center, we could cut that out. I mean, add more sound there. If I turn off the mapping, you'll see that this PA is coming out all the way up to here. So if I grab this line and start to toe it in till it reaches the front row, which is right there, as you saw the wide coverage, then I can actually copy and paste that and go to the other side if I need to. Should be 7. And there we go. Now I've reached up to here. So if I go and turn on the mapping again and it's only the top parts, now I've actually honed in a little bit more. But if you notice, I've lost a little bit of pressure on the outside area, and now the coverage of the PA is going to be a little bit off on my second floor. My stereo image is going to be off on my second floor and third floor. So you got to be careful when you decide to toe in and out your speakers. But this is a great way to play with that and figure those types of problems out. Next question. Vantage. Well, in the questionnaire. See. Then, okay, one second. Fernando, I can't make you only headwinds. Moving forward, which GLL file should I use to input event 218 subs into eFocus softwares? Okay, so the event 218 sub is actually inside of the same GLL as the event 208 and 210. If you wanted the 121 sub, that would be in the 212 eFocus, 212 event GLL. And then if you wanted the new series of events, the event 26 with the event 115, that would all be in the event 26 GLL as well. That's where you'll find this. Jono, does the height change points automatically if you have objects behind? Sorry, let me check the question. Behind the truss screen. No, these are all the angles. These GLOs only do what you tell it to do. The calculations is just an algorithm that sees it from the PA to your audience area. It doesn't know that there's a truss in front of you. it doesn't know that there's a screen in front of you. You have to make sure that you put these in places that allows you to calculate these things properly. How do you set, Carl, how do you set the grid spacing, your top grid spacing at 5 meters? So this little average grid spacing all depends on how close you're zooming into the project. If I zoom further into the project, you're going to slowly see that the metering of those cubes will start to change once it loads. I'll take off the mapping to load a little faster. See? Now it's at 2 meters, now it's at 1 meters, and so on and so forth. So the scaling of those little grids changes only when you're zooming in and out of the project. You had another one. Do you recommend using autosplay? Yes, I always use autosplay. Now I don't use autosplay as the final choice. So there are many times that I go in and start moving the angles by itself. Here's a great example. This speaker that I first used over here, you can see it in the second in the side view. I'm not hitting the first row of the balconies right now. I can actually grab this and move it down a little bit. That's that angle of that one box. But I saw that it moved the other boxes, but that's okay. I can go in and start changing those angles. So you can use the autosplay to get you as close as possible to what you want it to be, or what at least the computer tells it to be, and then you can do the rest of the adjustments yourself. I would go as far to say that I'm 98%. You don't leave the autosplay exactly how it is. You know, I do a lot of other calculations with autosplay to see which is the one that falls best in place, you know, between conventional, spiral, or accurate. And then from there, I kind of make my own decisions. I pick the one that falls into place the best for me, and then I make my tiny changes. Raise the PA a little bit, change the angles of a degree or two if I need to, you know, just try to maximize what I need from my PA. But yes, I do recommend using autosplay. Next, Lewis. Hi, in the side view window, is it possible to change the viewpoint? So, okay, yes, this is actually where the, what's it called? The selection plane comes into play. If I don't want to see my PA from the side angle and I want to get an up front view of my PA, all I got to do is select that selection plane. Your cursor will become a crosshair, and then draw a line in front with once. Once you do that, if you look at the bottom screen now, it has changed the angle of my viewpoint of the side view. But as you notice, it's only because I'm selecting the selection plane. If I select a PA again, let's say the right side, it goes to the viewpoint of the right side. I could also lock that view as well. If I want to completely see it from the front as well, all I got to do is go to the side view. It'll say selection plane 1, because that's what I have selected, selection plane, and I will lock it in place. Now when I go and select another speaker, so it will not change its perspective. Jan, what about if you are inside and have reflective walls? Okay, Ease Focus is not the program you want to use to see reflections. This only calculates open air of the speakers. There's nothing that indicates reverberation, slapbacks, and things like that. This is only so we can calculate the angles of our speakers, see the coverage of our area as a direct line of sight. If you have a project and you have a lot of reverberation in your area and you need to calculate that, you would want to use Ease, the full-blown Ease. That allows you to put what type of walls you're using, what kind of seatings you're using, and get real in-depth into your projects. But 98% of the times, I don't worry about the reflections in my rooms when I'm doing, you know, my main productions and stuff like that. I want to make sure that my coverage is fine. Because if my coverage of my speakers and directivity of my speakers is hitting the people where I want it, it's going to be louder than my reverberation. It's going to be louder and more direct than my slapback, thus eliminating those possibilities for your audience areas. You know, if you know you have a wall at the back of the room, you know, maybe you can select a cross off in your audience area. I can say, hey, my audience area down here doesn't end at 75, it ends at 70 meters. You know, and that's a total of 5 meters of space. So now you don't have your top speaker isn't shooting directly into the wall, causing a slapback. You know, you can do those things in your own head and then adjust it here to get your proper angles. So yeah, once again, we can't see reverberation or any slapbacks or any transients of exterior walls and stuff like that, but we can at least take mental notes and change things accordingly here so that way we can attack our live situation better. I hope that answers that for you, Jen. Nicholas. What about frequency response and receivers? Well, why you don't use I'm sorry, popular question. Why don't you use that while positioning angle? You can totally use that. I was gonna get into microphones and stuff a little bit later, but let's do that. Let's do that here. Calculating your angles, yeah, you can definitely put in your microphones to see your coverage of your frequencies amongst distances. That is not a problem at all. But it's not going to change the way you press the button auto split or place your height of your speaker. The best thing that this is going to help you with is when we are balancing out the angles of each box. Definitely, we'll be able to cover each area better. This also comes in more into play when we're using our DOS aim, which would be another webinar at the end of the month. We can see the different changes between each area, plus add, we have distance? No, this is just a frequency. If each microphone is placed at a certain spot, then we can see it covered. So yes, we can use microphones and receivers with our frequency response to select our angles and display them accordingly. That is definitely possible. Are the video manuals and tutorials available for each focus? Well, this is one of those videos that you're seeing right now. But manuals and tutorials, I'm pretty sure East Focus AMFG has their own manuals online, which you can go ahead and download. We will be making more little shorts in the future of East Focus, but that will be as time go on. This has been recorded. No. Which, let's talk to Danielle again. Then, which space, stage, or other things, drawing programs you use? Okay, so if you wanted to make your own little DWG file in the back, a lot of our clients use AutoCAD, a lot of them use SketchUp, and just those are pretty much the main two, AutoCAD and SketchUp, just so you can get the lines, dimensions. But just remember, this software does not, you can't import DWG files. So if you use any of these sketching programs, you have to take a screenshot of the image and then make sure you do a proper calculation of a distance, so you know that that falls into a proper scaling to this program. If there are pillars in the audience area or obstacles, how do you draw them in the program? So yeah, you can't draw obstacles in the program. There are no pillars or anything like that. You can make note of that in the drawings that you put in there, but again, we can't put something in there to block the sound. This isn't a project as an ease where it takes coverage. I mean, reverberations, transients, and slapbacks from a room into account. This only does open air to your audience area. We will make a video available on YouTube shortly. I don't think it'll be this one, but there will be another one up there soon. If this one does get on, well then, lucky me, I get to be on YouTube. Does anybody have any other questions in the meantime? Richard? Give you guys another minute to decide if you have another question. If not, that will conclude today's webinar. Any other questions you guys would need answered or some help, you can definitely reach me at my email, gortiz@dosaudio.com. You can find us on Facebook, Instagram, and YouTube. Let us know if there's anything else that we can help you out with. Again, my name is Giovanni Ortiz. I'm the applications manager and tech support for DOS Audio of America, and we will be in communication soon, guys. Hope you guys have a great day. Oh, one more question. I had a problem with importing the GLO. Why don't you send me an email, Michael, and I will get to you and be able to help you with that individually. Okay? All right, guys. You have a good day. Thank you for joining.